How to graph y equals the square root of the quantity r squared minus x squared. Hi, this is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. First of all, let's talk about where this equation came from. Y equals the square root of r squared minus x squared. We're going to start with the equation of a circle whose center is at the origin and has a radius of length r. And that standard equation is x squared plus y squared equals r squared. We're going to solve this for y. So first I'm going to subtract x squared from both sides. Then I need to take the square root of both sides. Keep in mind that the square root, there are two of them, a positive and a negative answer here. And so we get y is equal to plus or minus the square root of that quantity. Now the positive square root turns out to be the top half of the semicircle, and the negative square root turns out to be the bottom half of the semicircle. So this is a general equation for any number r, so we're going to look at a specific value. So we're going to start with r being equal to 5. And so we're going to look at the square root, the positive square root of the quantity 25 minus x squared. So since the radius is 5, we have to keep our numbers between 5 and negative 5 inclusive. And you may say why? Well, let's try 6. If I use 6 for x, the square root of 25 minus 6 squared, 25 minus 36 is negative 11. Non-real answer. Similarly, if we go with negative 6, 25 minus the quantity negative 6 squared is also going to be an imaginary or complex number. So we need to keep between 5 and negative 5 inclusive. So looking at some positive numbers, we picked these. I'll ask you to pause the video and complete the table. Some of these you're going to need to use a calculator. So for 5, we get 0, and then for 4, we're going to get 3. 3, we're going to get 4. Now 2, we got the square root of 21, which we had to approximate about 4.6. Square root of 24 is almost 5, but it's a little bit less, 4.9. And 0, we do get 5. So I'd still like to go to negative 5, so I'm going to continue the table and use the opposites of these values right here. And you may want to pause again and complete the table. So completing the table, we get 0 here, and then we'll just go ahead and fill in the rest of the values. They're pretty much the same values we got before, just using a negative. So we're going to go ahead and plot these points, going from right to left this time, 5, 0, 4, 3, 3, 4, and then with the decimals 2, 4.6, 1 almost 5, 4.9, and then the y-intercept at 0, 5. At negative 1, again, we're at the 4.9. Negative 2, we got the 4.6. Negative 3, negative 4, and negative 5. And you can see we've got symmetry here about the y-axis. Okay. So drawing the curve does definitely look like half of a circle, a semicircle. So the terminology, we've got the center of the circle, which is not part of the circle, but helps us get it. We also know that the radius is 5 in many different directions. From the center to any point on the circle is going to be that 5. So the semicircle dance, you really only need 3 points to make a semicircle. So go ahead and plot those now. Okay, so 5, 0, 0, 5, and negative 5, 0. Those are the easy points to plot. The radius is 5. However, because we have Pythagorean triples in these, we can plot 4 more. I want to make sure you realize that. So for example, at 4, 3, we've got a 3, 4, 5 triangle. At 3, 4, we have a 3, 4, 5 triangle because the radius is 5. Negative 3, 4, we've got a 3, 4, 5 triangle. And negative 4, 3, also another 3, 4, 5 triangle. Special case, though, for this particular radius. Drawing the curve, we get that nice semicircle. Again, all you need are the x and y intercepts to plot a semicircle and make it look like a semicircle. We will do a second example because not always is the radius going to be that nice number 5 and get so many Pythagorean triples. This equation is of the proper form. R squared is 16, so the radius is 4, positive 4, the length is positive. And so it's from the center, we go 4 units in each direction. And so we have those 3 points. And then we draw and make it look like a semicircle. So domain and range, we'll go back to y equals radical, the quantity 25 minus x squared. And you can see that the domain is between 5 and negative 5 inclusive, as we said before. And this is how we would write that with set notation. The range only includes the real numbers 0 through 5 inclusive. And this is how we would write that. And here's the domain and range. Where in the world would you see this curve? Hopefully you'd see it a lot of places. We found this one place here. Thought that was kind of cool. And so we invite you to interact with the other videos in this series.